Welcome to Study Loop.
.76. So we have the radiation curve of an incandescent solid here and its spectral pattern. Here we have the spectral pattern and radiation curve of the emissions of a gas. Here we have the radiation curve of this gas absorbing the being put in front of our incandescent solid and absorbing light. And here we have the spectral pattern of this light viewed through a piece of green glass. And so we want to first put in what the spectral pattern here is, and then we want to put in what the radiation curve is here for the green piece of glass. So if the emission spectrum has dark spots, or is dark except for lines that occur where there's where the frequency of light corresponds to an energy transition in the atom, then when it's absorbing things, it has the exact same energies, but it's going to have basically black and white reversed in this part. So we draw in a black line everywhere there's a dip missing from the transmitted light. And then also we're told that since this has sort of a bell shape, it's also dark at the ends over here, although that's maybe not a level of detail we need to get into. Now here, we can see sort of from how these work that wherever there's a light, whether it's light, then there's going to be more intensity in the radiation curve, and when it's dark, there's going to be less intensity. So the radiation curve for the source of light viewed through a piece of green glass is going to be sort of a narrow peak. It's not quite like a spike like these, that's centered around the middle of the visible spectrum, which is green. So, this makes sense that this is a piece of green glass.